this episode, we move from securing storage itself to securing the paths that reach cloud services, because a large portion of cloud risk comes from how services are exposed and how traffic is allowed to flow. When a service is reachable from the public internet, it is not automatically insecure, but it is automatically visible to far more potential attackers, which increases the chances of probing, credential abuse, and misconfiguration being exploited. Private endpoints and scoped connectivity are two ideas that help reduce that exposure by narrowing where access can originate and how traffic is routed. A private endpoint is a way to reach a managed cloud service through a private network path rather than a public one. And scoped connectivity is the broader habit of limiting network reachability to only what is necessary for the intended users and systems. The beginner-friendly goal is not to memorize networking details, but to understand why reducing exposure surfaces matters, how private connectivity changes the risk picture, and how to think about reachability as a deliberate design choice instead of an accidental default. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A strong starting point is to clarify the difference between a service being protected and a service being reachable. Protection includes identity checks, authorization rules, encryption, and monitoring, while reachability is about whether a network path exists from an outside source to the service at all. Many cloud services are well protected at the application layer, but if they are reachable publicly, attackers can still hammer on them, attempt credential stuffing, exploit weak configurations, and pressure your detection and incident response. Reachability also affects mistakes, because a small misconfiguration in authentication or authorization is much more dangerous when the service is reachable from anywhere. Scoped connectivity means you treat reachability as a controlled resource, where you decide which networks, which applications, and which administrative paths can talk to the service. This is similar to choosing whether a building has a front door open to the street or a door that can only be reached from inside a gated campus. The interior door might still require a badge, but the fact that it is inside a gate reduces random foot traffic and lowers the chance of opportunistic intrusion. Private endpoints are one mechanism that supports scoped connectivity by changing how you connect to manage services. In a simplified sense, many cloud services live behind provider-managed infrastructure, and by default, they may offer public endpoints, meaning they can be reached through the internet using standard routing. A private endpoint allows you to map that service access to a private address within your own network space, so that traffic stays inside a controlled network boundary. Instead of your application reaching out to a public address across the internet, it reaches a private address that is only routable from within your environment. The service is still managed by the provider, but the path to it is more constrained. This reduces the chance that an attacker on the internet can directly reach the service, and it can reduce certain classes of scanning and probing simply because the service no longer presents a public surface. For beginners, the key idea is that private endpoints are about shrinking who can even knock on the door, not about removing the need for locks on the door. It is important to understand that private connectivity does not replace identity and authorization, it complements them. If an attacker gains access inside your network or compromises an application that has private access, they may still reach the service through the private endpoint. That is why the security posture still relies on least privilege identities, tight permission scopes, and good monitoring. Private endpoints reduce exposure to external attackers and reduce accidental public reachability, but they do not eliminate the risk of internal misuse or compromised credentials. A common beginner misconception is to treat private network access as equivalent to trusted access, which leads to environments where services are reachable privately but are weakly authenticated. That is a dangerous pattern because it assumes the internal network is safe, when modern attacks often begin with a foothold inside the environment. Scoped connectivity should be paired with strong identity, so that even if a private path exists, only the right identities can use it and only for the right actions. Think of it as defense in depth: fewer paths, fewer attackers, and stronger checks on the paths that remain. To see why scoped connectivity matters, consider the difference between an access policy and an access path. An access policy might say only a specific role can read data from a storage service. But if the service is publicly reachable, attackers can still generate a huge amount of traffic, attempt to exploit implementation weaknesses, or target the policy layer with password guessing and token theft attempts. If the service is privately reachable, the attacker often needs an additional step, like compromising a system within the allowed network scope or obtaining a position on a trusted network. That extra step increases attacker effort and often increases your chance to detect them earlier, because internal movement tends to leave signals. Scope connectivity also reduces accidental exposure because the default posture can be deny by network rather than allow by network, meaning services are not reachable unless you intentionally connect them. This is especially useful for sensitive services like storage, databases, and management interfaces, where a single misconfiguration can have large consequences. For beginners, this is a practical mental model. Policy controls who should have access, and connectivity controls who can even try. A major part of making scoped connectivity work is being clear about the different kinds of traffic that need to reach cloud services, because different traffic types deserve different paths. Application traffic is the normal flow between your apps and the managed services they depend on, such as retrieving objects, writing logs, or querying a database. Administrative traffic is the access used by humans to manage the service, change settings, review data, or troubleshoot issues. Integration traffic might involve third-party services, partner connections, or external systems that legitimately need to exchange data. If you treat all these traffic types the same, you will likely end up with broad reachability that is convenient but risky. Scoped connectivity encourages you to separate these paths and apply different controls, such as allowing application traffic through private endpoints while keeping administrative access constrained to a small set of trusted networks or dedicated management environments. It also encourages you to reduce the use of direct human access to core services when possible, because human access tends to be harder to baseline and easier to misuse. The beginner takeaway is that you do not have one single access path. You have multiple, and each should be justified. Another foundational idea is the principle of explicit routing, which means you know exactly how traffic reaches a service and you can explain it. In cloud environments, networking can become complex quickly, and complexity often hides exposure. If you cannot explain whether a service is reachable from the internet, from partner networks, from internal application subnets, or from administrative networks, you are likely to have accidental pathways you did not intend. Private endpoints support explicit routing because they create a deliberate private path that you can map and monitor. Scope connectivity also includes restricting which subnets or network segments can reach the private endpoint, because simply having a private endpoint does not automatically mean it is tightly scoped. A good mental model is that private is not the same as limited. Private means not internet routable, but it can still be widely reachable inside your environment if you allow it. Beginners should focus on the difference between private and narrow, because narrow reachability is what reduces blast radius when something inside the environment is compromised. Monitoring is another key part of securely accessing services through private connectivity, because when you shrink the external surface, you shift attention to internal signals. You want to know which identities are using the private path, which applications are generating traffic, and whether the traffic matches expected patterns. If you see a private endpoint suddenly used by a new identity, or from a new network segment, or at unusual volume, that is an anomaly worth investigating. This is similar to storage access monitoring, but now you are also monitoring the connectivity layer, which can reveal early movement by an attacker. For example, if an attacker compromises a workload in one segment and then starts reaching out to services through private endpoints, the network usage itself can be a sign of lateral movement. Logging discipline still matters, because you need records of connections and access events to understand what happened. A beginner-friendly view is that private connectivity reduces noise from random internet traffic, which can make internal anomalies easier to see, but only if you actually observe them. There are also operational benefits and trade-offs that matter for security decisions, because the best design is one teams will keep rather than bypass. Private endpoints can improve predictability because traffic stays inside controlled paths, but they can also introduce dependency on internal network design and name resolution behavior, which means misconfigurations can break connectivity. Scoped connectivity can reduce attack surface, but if it is too restrictive or poorly planned, teams will create exceptions that reintroduce risk. This is why durable designs aim to make the secure path reliable and easy to use, so teams are not tempted to open public access as a shortcut. It also means planning for legitimate external needs, such as third-party integrations, and designing those needs with controlled patterns rather than ad hoc exposure. Beginners should recognize that security architecture is not just about making the tightest possible lock. It is about making a usable system where the safe approach remains the easiest approach under time pressure. If your connectivity design is fragile, it will not survive real operations. A particularly important concept is scoping connectivity to boundaries that match data sensitivity and service criticality. Not every service needs the same exposure posture, and risk-based thinking helps you decide where private endpoints are most valuable. Services that store sensitive data, services that hold credentials or secrets, and services that control infrastructure settings are often high-value targets. For these services, reducing public reachability can significantly reduce attack opportunities and the consequences of small misconfigurations. For lower-risk services, public reachability with strong identity controls might be acceptable, especially if the service is intentionally user-facing. The point is not to declare that everything must be private. The point is to make exposure decisions deliberately and align them with what you are protecting. Scope connectivity also involves limiting east-west access inside your environment, so that even if one application is compromised, it cannot automatically reach every service. Tight boundaries apply here just as they do in storage permissions, because network scope can serve as another boundary that contains compromise. When you put this all together, securely accessing cloud services through private endpoints and scope connectivity is about controlling reachability as a first-class security decision. Private endpoints help by moving service access off the public internet and into private network space, which reduces opportunistic scanning and limits who can even attempt to connect. Scope connectivity ensures that private does not become wide open inside the environment by limiting which networks and which workloads can reach which services. Strong identity and authorization remain essential because private paths do not guarantee trust, and compromised internal identities are a real threat. Monitoring and logging discipline provide the visibility needed to detect abuse, especially as the external noise decreases and internal patterns become clearer. Finally, durable designs consider operational reality, making the secure path reliable so teams do not create risky exceptions. The practical outcome is a cloud environment where access paths are fewer, clearer, and more controllable, which lowers risk and makes both prevention and detection more effective over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.